Hi, it's Miss Rasmussen again, making another little video. This one might be a little longer than the others, just because I'm choosing to do my favorite lesson that I've made on solving systems of equations graphically. And it's actually using a real life example of how using this would be helpful in a financial situation, which is really important for the kids these days. And I'm glad we're pushing that direction in math to teach more financial literacy because it's super important. So the topic overall is systems of equations, solving systems of equations graphically. I have my little agenda. We're not going to go through the whole entire thing because that would be a whole 45-minute lesson for a class. But I'm going to get to focus on the mini lesson, which will show you how to solve systems of equations graphically, as well as, in a real life situation. So the essential question is, can we use systems of linear equations in order to solve real world problems? That's our goal. So this would be my warm up, because hopefully if I was teaching this to class, they would already know how to identify graphs of linear functions and their equations. So they would match which ones you could see if you can do that right now, because if you can't, it's kind of a sign that this lesson might not go as smoothly because the lesson is designed in the sequence of the pacing guide, where this would be first, and then we'd be learning how to do multiple lines at the same time. You could check, you could pause the video if you want to work on this and see if you could do it. A little reminder, y equals mx plus b is always our guide. So these are the two most important parts of the equation. We would use it to see where we're going to start. So for the first one, and I'll just do the first one, and then if you want to pause video, like I said, and do what you can. So the y-intercept, that's the b in the equation, is -1. So this is the only line that I see, the one that I highlighted in yellow, the third one, that intercepts the y-axis at -1. So we can go ahead and say that that's the right answer, but we want to double check. I always tell my students to double check because you never know. The slope is -7/2. So that means we're going to check to see, is it going down 7? And of course, we don't have room up there, so we'll have to go the opposite way. Up 7, 1, 2, 3, 4, 5, 6, 7 over 2. So normally you go down if it's negative and go from left to right. But in this case, if you don't have enough room, you just work backwards and look. The line is still negative, and a lot of students kind of have trouble understanding this. For some reason, the line is negative because from left to right, it's going down. So the slope, I should say, is negative. So that would be the line for this, and we match that up. And then you do the same for the rest of the questions, and you can try that to see what level of expertise you are at this. So the goal of this lesson is to be able to solve systems of linear equations graphically. And we're meeting a Common Core standard that's listed there. And we have some vocabulary that we want to know. The solution, a value we can put in place of a variable such as x and y in this case, that make the equation true. So obviously solution has many different definitions in life. This is the mathematical definition for this situation. And our solutions are gonna be, our solution, because it's only gonna have one, is going to be in the form of an ordered pair, x comma y. And we're gonna be able to plug those into the equation, and that means you'll see that the lines intersect. And that's the point of intersection, the point at which two lines cross each other. So here is what I want to focus on for this lesson today. We have Josh here, and he's in trouble for running up a huge bill downloading music on iTunes. Each song costs $2 to download. So he's just downloading as many songs as he wants. And obviously sometimes kids have no concept of what that means. So his grandma ends up getting a bill and she's shocked at how much it costs, and she's very mad, and she's planning on punishing him. So he discovers that Apple Music offers unlimited downloads for a flat rate of $10. Plus, you can listen to any song you want on their radio stations. So Josh has to figure out if this is a cheaper option for him so that his grandma doesn't have to pay a huge bill every month and that he can still continue to get the songs he wants. So something my students are very used to me doing is leaving little cues in word problems, because word problems are the demise of a lot of people in math, but they are the most important part because I always say it's like where the rubber meets the road. So you can learn all the skills you want and memorize all the formulas you want, but if you don't know how to apply them in real life, what use are they really to you? So I focus a lot on word problems. So I bolded the word flat, and you'll see why, because it's a flat rate, but it also has a lot to do with the slope. So the first step is to write a system of equations to model this situation. So the first line, and I always like to use my different colors, is the situation that he's in right now. $2 to download each song, and each is a keyword. And my students, I try to make sure they understand that the word each usually implies multiplication or division, and per is the same thing. So just get your mind thinking that way. So $2 per song. And remember, we're talking about linear equations, which would be y equals mx plus b. So, and with the class, we'd have a lot of discussion. What do you think that means? You guys, you students would come up with it themselves, the equation. And through that discussion, we would discover that this line has a slope of $2 per song. So you would multiply $2 by the amount of songs that you download, and it's going to vary each month. So the equation for this first line would be 2x. And there is no y-intercept because there's no starting fee. So it costs $0 to download 0 songs. So our graph is going to start at 0, 0 at the origin and go up positively. Every 2 over 1 is going to be the slope, up 2 over 1. Every song you download, every one song you download, you go up $2. So that's our first system. And I'll color that in pink because we're going to need that later once we graph. So the next question is where we where we highlighted in yellow, flat rate of $10. So in my discussion with my students, I would say, how much will Josh have to pay if he downloads 0 songs? The answer to that would be 10. You have to pay $10 no matter what. $10 for 0 songs, $10 for 500 songs. It's a flat rate. It's not, there's no slope because it doesn't depend on how many songs you pay. It's just y equals 10. Because it's going to be a flat line. You'll see when we graph through 10 at the y-axis. So it has a y-intercept and it doesn't have a slope. So then we want to figure out, what do the x values represent? So if we have a graph, what would we label the x-axis? We would call this the number of songs. And then the y value would be the cost. Because the reason we're crossing the y-axis at $10 is because it's going to cost $10 for 0 songs. It's going to cost $10 no matter what. So now we get to graph it, which is my favorite part because I'm very visual. So I like to see things written out this way. So first we have to graph the equations, and that means we should rewrite them here. And I'm going to highlight them in the corresponding colors that I want them to be. So we know that these are going to be, the x value is going to be the number of songs, and the y value is going to be the cost. When we get a blank graph like this, it's very important to think about your scale. So I can scale the x-axis by 1s, just a regular 1, 2, 3, 4, 5, 6, 7. And I could keep going however far I want. Or I actually could spread it out a little more if I want to, but considering I don't, I know what the graph is going to look like because I've done this lesson a million times. So I would choose to spread it out 1, skip 1, 2, because I know the situation. But when you don't, and you're just doing it, just start with 1 because you don't want to make a mistake and have to erase it and redo it. So then the y is, we need to worry about 10. So let's see how many we have there. 1, 2, 3, 4, 5, 6, 7. We have more than enough to go by 10 because we want to see past 10 also. We don't want to just leave it. If this was only 10, we might want to go by 2 so we could zoom out a little so we could see closer, if that makes sense. So 2, 3, 4, 5, 6, 7. Okay. So the first line is going to, we said go through the origin and then go up 2 over 1. That's our slope. And that's our first line. I'll highlight it in pink. So we know, and also something that I am guilty of not doing as much as I should, you should always label the lines. Definitely guilty of that. So the second line, as we said, the y-intercept is at 10. So see where I have that, 10. And it's a flat rate, no matter how many songs you download, is going to be $10. So another thing that has to do with the situation is time, because it's $10 per month, but we don't have to worry about that because when we see this, we will get all the information we need. So that's that. And let me just make, because I get a little obsessive with my colors. Let me make sure I color the y-intercept or lack thereof for the pink line. Oh, and I almost forgot again to label this line. Very important. So what are the coordinates of the point of intersection? This little green one that I highlighted here, it's going to be 5, 10. Because that's the point. It goes, the x value of the point of intersection is 5 and the y value is 10. So this is the questions I love that my students don't love because these are the kind of questions that really make math meaningful in life. So explain what the point of intersection means in the context of the problem. So this is a point where we break out into like little discussion, turn-in talks and stuff. And we would come to the conclusion that the point of intersection is the point at which both scenarios cost the same amount of money. So whether he does a subscription or he downloads per song, at the point of intersection, they both cost the same. So it is the point on the graph where both situations, both situations for downloading songs cost the same. And just this is like, I modeled this off of the New York City Regents 4-point question that has been this way for a few times. If it's a system of equation, these are the kind of questions that they're asking on the 4-point question, which is a big deal. And I always push for the 4-point questions because if you can understand a 4-point question, then you're going to understand the rest of the Regents. So I focus a lot on the 4-point questions because, like I said, if you can get that, you can get the majority of the questions on the test. So most of the time when it has to do with cost in system of equations and there's a point of intersection, nor usually it means it costs the same, but you got to be careful about what it's asking. So you always have to read the directions because sometimes it might be asking something else. So it says if Josh was downloading an average of 9 songs, so now they're giving us another scenario to look at, an average of 9 songs per month. So I'm just going to make a blue line there so we can focus on that. Would the Apple Music subscription save his grandma any money? So we would look and we would see that this line here is trending upward and it's going to meet 10 is going to be its next. So it's going to be 1610 over here somewhere, which isn't really that important. So it's not that big of a deal that it doesn't make it. We know that it's going to be more money than the $10 subscription. So if he downloads an average of 9 songs per month, how much is it going to cost him if he does it per song? The answer would be $16. Yes, $16. I'm sorry, that should be 9 here. I knew something looked wrong. So it would be $16 if he downloaded per song. Whereas if he just stuck with the subscription, it would just be $10. So yes, it would be $6 cheaper. So you can see what the question is asking. Will it save her money if he does the subscription? Yes, it would be $6 cheaper. And you can add then downloading per song. Just, I always say, make sure you box yourself in as close as you can to the details, because when people are grading these tests, they don't know you and they don't know what you mean. So just try to be as specific as possible. So yes, it would be $6 cheaper than downloading per song. So what is the number of songs where the subscription to Apple Music would begin to save Josh's grandmother money? So we know that this is the solution. At 5 songs will cost the same, whether he downloads them per song or whether he gets the subscription. So that means 6 or more songs would be saving his grandmother money, right? So 5 songs is going to cost exactly the same, so it doesn't matter which one they choose. But after 6 or more songs, the subscription is going to be the better choice because it's going to save them money. So you could describe that as saying if X is greater than or equal to 6. You could just put that, or you would maybe want to write a full sentence that says after if Josh downloads 6 or more songs, he would be saving his grandma money by using the subscription. Or you could say X is greater than or equal to 6, just to show that 6 or more. If you were going to say 5, you would have to say X is greater than 5, because it can't be 5 because then it equals the same, if that makes sense. They're only saving money if it's more than 5, not at 5. So there you go. This is a question I tweaked and made up myself based on other Regents questions like it, 4-point. I would have some independent practice if this was a real class for IXL for you to work on. And then we have our exit ticket, which I like to leave in the video for anyone to leave in the comments to see if my goal is for the students to be able to identify the solution of a system of equations. So my exit ticket should measure that, right? So this is just a very quick, yes or no, multiple choice, pick the answer. So if the students get it right, or the students that get it right, I know that they understand how to identify visually on a graph the solution to systems of equations. So that's just my little teacher input there. Feel free to answer it and put your answer in the comments. And I hope you enjoyed this video.